Hi everyone. Today topic is signal processing systems. Signal processing system. What is system? In previous class we are also discussing a system is an entity. Entity means number of inputs. A system is an entity that processes one or more input signals in order to produce one or more output signals. That means the major working function of system, it will receive number of input signals and propagates or transmitted number of output signals from the output side. So in this diagram also we are seeing several elements to convert the signals is in the form of either c by d or d by c. For example, in signal processing systems, the signal will be entering to the system that will be converted is in the form of continuous to discrete time signals, and then it will propagates through the discrete time system. Discrete time system, already signal is converted is in the form of continuous to discrete. That's why it will receiving continuous signals within the help of discrete time system, and then it will propagate or transmit to the next converter. It will also convert the discrete to continuous time signals by using d by c converter. The below diagram is also exactly a reverse operation of the above diagram. From the above diagram we are using c by d and d by c. From the below diagram we are using d by c and c by d. That means the signal will be converted continuous to discrete or discrete to continuous. Why we are converted the signals either continuous to discrete or discrete to continuous? For example, in a previous class we are seeing these are the these are the two different signals. One is continuous signal or voice signal or analog signal. Continuous signal or voice signal or analog signal. For example, you are taking an example mobile communication. In mobile communication system, human beings produce voice signal that is in the form of analog. But in an electronic device, it will receive analog signal, and must and should it will be converted is in the form of digital. So the digital signal will be converted three steps: analog to digital signal process, internally including three conversions, not directly converted analog to digital. First, continuous time signal or analog signal will be converted to the discrete signal. Discrete means to split it the analog signals to the equal intervals, and then after it will converted quantized signal. That means it will assigning some individual intervals, and then after finally it will convert up high state and low state. High state means positive signal 1 and low state means negative signal 0. So in three process we are using sampler. Sampler is used to convert the continuous time signals to the discrete time signal, and quantizer is used to convert the discrete to quantizing signals, and then after we are using a by d converter. Finally, we are using a by d converter. We can easily convert the analog to digital signals. This is the internal process of signal conversions. Internal process of signal conversions. So, in this also we are using here in this also we are using signal processing system, various blocks or various elements to convert the given information or receiving information, either d by c continuous to discrete or discrete to continuous, again discrete to continuous or continuous to discrete. That means sender receiver will receiving only analog signals, and then after we can internally converting the information is in digital to analog or digital to analog. That will be is indicates as continuous signal or discrete signal or quantized signal or digital signal or analog signal. These are the different signals to convert the information in different forms. Next we are seeing the communication system. Communication system. Already from the above diagram, the signal will be converted in different forms. The converted information, for example, is passing through transmitter to channel and receiver. ORR. It is a simple general structure of communication system. In communication system, message signal will be entering to the transmitter. Message signal will be entering to the transmitter. Transmitter transmitting the transmitted signals through the channel, and it will be sending to the receiver. It is a simplest diagram how to signal will be converted from source to destination or transmitter to receiver. Transmitter to receiver. Already from the above diagram we are discussing how the signal will be converted in various blocks, and finally this is the simple diagram how to signal will be transmitted from transmitter to receiver. Next one is control systems. Control systems. Control systems means when I am applying a reference signal from the input side. When I am applying input reference input signal from the input side, in this we are using different blocks: controller, plant and sensor. Controller, plant and sensor. If the receiving signal purely quality signal, that will be directly sending to the output side. If the input side signal will be some noise will be added, at the situation controller and sensor will be activated, and that will be eliminated by using feedback network or feedback signals, and then after regenerated signal will be sending to the output side. Two steps: if the input signal is pure signal, that will be directly sending from input to output. If the input signal will be adding some error, that will be corrected, and then after it will be sending from input to output. This is a general structure of feedback control system. Feedback control system. Controller means it will balancing the signals. It will balancing the signals and providing additional frequency to the output side. Next one is why study signals and systems. Next one is why we are study signals and systems. Engineers build systems that process manipulate signals. We need a formal mathematical framework for the study of such systems. Such a framework is necessary in order to ensure that a system will meet the required specifications or performance and safety. If a system fails to meet required specifications or fail to work altogether, negative consequences usually ensue. When a system fails to operate as expected, the consequences can sometimes to be catastrophic. 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 The overall meaning of why we are study this signals and systems. We know the behavior of these signals, and we know the conversion of the signals in various systems, and how it will be works in various networks. That's why we are using several signals. So this is the brief information of signal processing system. Signal processing system. Any signal processing system, it will be used. Any signal processing system, it will be used to convert the signals in various forms, either serial to parallel, parallel to serial, analog to digital, digital to analog, continuous to discrete, discrete to continuous, discrete to quantized, quantized to discrete. So these are the different conversions methods to improve the quality of the signals. The main concept of signal processing system, one is signal conversion, and second one is it will providing quality of the signals. Otherwise some systems will be faces some problems. So at the situation we are using signal processing system, and we can easily convert the information from one place to another place, or one block to another block, or one form to another form. Next, signals. Signals already we are discussed. Earlier we are discussed, introduced CT, continuous time signal, and discrete time signals. A continuous time signal is called a function. CT means function. A discrete time signal is called a sequence. Already we know discrete time signal will splitted or divided or separated equal intervals. That's why it is called sequence. CT means function, DT means sequence. Although strictly speaking, a sequence is a special case of a function, we will use the term function exclusively to mean a function that is not a sequence. The nth element of a sequence, x, is denoted as either x of n or xn. This is the process of signal conversions and signal processing systems. Next class we are discussing notation functions, Vences function values, and event signals. Thank you.